All right, in our next video here, we're going to combine all the chain rule that we've practiced and combine it with product and quotient rule. So again, I just want to remind us of that saying, derivative of the outside, keep the inside, times the derivative of the inside. And I'll throw up there that rule again for chain. The derivative of f of g of x, derivative of the outside, so that's f prime of x, keep the inside, times the derivative of the inside. All right, so let's take a look at these two examples. We have, what do I keep clicking? So we have 5 sine of 7x versus 5x sine of 7x. The only difference in there is the x, and it makes a huge difference. It's crazy. It makes such a big difference. And here's why. So I want you to take whatever colors you have, and let's just kind of, if you have any colored pencils here, it's a good time to put them in here. So this is 5 times sine of 7x, right? Notice how this does not have a 5, which just makes it a coefficient, not a product. Versus this guy over here, which is 5x times the sine of 7x. Because they both have x's, it is now a product rule. And that is the big difference. So we have to be very, very careful on whether we have coefficients or we have products. And it just comes back to reading it out loud, I think. This is just 5 sine of 7x. This is read 5x times the sine of 7x. And really, really read these things out loud to yourself. So I'm going to go ahead and derive both, and we'll talk about the big differences here. So we said this is just a coefficient. So if you recall, coefficients just come along for the ride. So this is just keep the coefficient. And now this is a chain because there's an inside here. Derivative of the outside. So sine becomes cosine. Keep the inside times the derivative of the inside times 7. And when I clean that up, I can multiply these two bad boys together. So I'm going to get 35 cosine of 7x. Now let's go ahead and look at that other example. So again, we said we have product rule because we have x's on both sides. So let's talk ourselves through product. So it's been a few days. Product was first derivative of the second plus second derivative of the first. So again, it's a lot of talking out loud. So let's go ahead. First, so I'm going to rewrite my first term down, times the derivative of the second. I'm just going to leave it blank for a moment. Leave some space there. Plus the second, so that's the sine of 7x, times the derivative of the first. Okay, so now I'm going to go ahead and fill in those derivatives. I need the derivative of the sine of 7x. So I'm going to write it over here, the sine of 7x. So it's chain because I have inside, outside. Derivative of the outside is cosine. Keep the inside times the derivative of the inside. It's linear, so times 7. Over here, I need the sine of the derivative of the first term. Well, the first term was 5x. That's linear. Its derivative is just 5. Look how very, very different these two derivatives are by having a coefficient versus having a product. So let's go ahead and finish this derivative. F prime of x equals, I can multiply those together. So that's 35x cosine of 7x plus 5 times the sine of 7x. Now, calculus-wise, it's over. It was over once I took the derivative. Now we're just going to clean up our algebra. It looks like, so here's my plus sign, right, guys? I'm looking for a GCF. Now, you can't touch the of part. You can't touch that trig stuff. The coefficients are going to be these outside terms that I'm looking at. Here and here on the plus sign, I can pull out a GCF of 5. Oops. So if I pull out a 5, so 35 divided by 5 is 7. I'm going to keep that x. Cosine of 7x plus 5 divided by 5 is 1. Sine of 7x. Obviously, I don't need a 1 there, but I'm just putting it there for the sake of it. This is probably what the multiple choice would look like. Number 2. So again, very similar. I have g of x equals 3 cosine of 8x versus g of x equals 3x times the cosine of 8x. So are you catching that difference? And again, I'm going to put brackets around the functions. That does not have an x, so that's a coefficient. It just comes along for the ride. This bear over here has an x on both sides, so I know it's a product rule. All right, so let's take a moment. Try this first one here, 2, the coefficient one. Pause it, give it a whirl, see what happens. So you can see my derivative. Again, those parentheses are important. I'm going to clean it up fully. So I am going to say I can multiply the 3, the negative, and the 8 to get negative 24 sine of 8x. Okay. Now over here, I got to talk myself through product again. And sometimes I just leave blanks like I did on that first example and go back and fill in the derivatives. So I'm going to say it's the first times the derivative of the second, which I'll leave blank, plus the second times the derivative of the first. Okay. So now I need to ask myself, what is the derivative of the cosine of 8x? And I'm hoping we can do that out loud, talk it out. Cosine becomes negative sine. Keep the inside times the derivative of the inside. And then the derivative of 3x, so that's linear, so just times 3 here. All right, and then again, calculus is done. Just have to memorize that rule, and now we're just going to clean it up. So you cannot cross over the plus sign, remember. Okay, you can't put things together on opposite sides of the plus sign. So just look at this side, maybe put an underline or a bracket around it. You can only put these stuff together here. So I can do 3x, a negative, and an 8. So I'm going to get negative 24x. And then I have the sine of 8x. Over here, I have 3 cosine of 8x. Okay, so when I'm cleaning up, I can only clean up things on each side of the plus sign. Now, if I want to pull out a GCF, that's fine. But again, only of the coefficients. So it looks like I can pull out a 3, and then I'm left with negative 8x sine of 8x plus 1 cosine of 8x. Okay. But as far as calculus goes, if you nailed this step, you're in amazing shape. And then we'll just kind of work on our algebra cleanup. All right, so they're going to get a little more interesting as we go on here. So this is read x times the square root of 2x minus 1. So I see a lot of x's, which is implying probably a product or quotient rule that's going to get involved here. So I'm going to rewrite this because I see a square root, of course. So I'm going to say this is really f of x equals, I have x times the quantity 2x minus 1 raised to the 1/2. Okay, so again, I'm going to stress that we're talking product because I have an x in front times this term with an x here. So it seems like a simple product. However, there's a chain involved because you have an inside and an outside. So once you get comfortable, like chain is pretty much in every problem that we do. We're always looking for this inside and outside. So I'm going to set it up in a very similar way. I'm going to say first term, derivative of the second, I'm going to leave some space, plus the second term times the derivative of the first. So I kind of get myself prepped. First derivative of the second derivative of the first. Now, one of them is super easy. I'm going to do this term. What was the derivative of x? It's linear. Its coefficient is just 1. So bam, that's easy. Now the second piece I'm going to do off to the side just to maybe make it clearer for some people. So I'm just going to rewrite it for myself. I have 2x minus 1 to the 1/2, and I want to derive it. So inside, outside. Derivative of the outside, so that's going to be 1/2. Keep the inside. This becomes a negative 1/2 because I have to subtract 1 times the derivative of the inside. 2x is linear, so that becomes 2. 1 is a constant, it becomes 0. So I'm going to say that's 1/2 times 2x minus 1 to the negative 1/2 times 2. Okay. So first derivative of the second plus second derivative of the first. Now remember, you cannot touch anything on the opposite sides of the plus sign. You're just cleaning up one side of the plus sign and then the other side. So calculus is done. We're just simple algebra now. I have an x, a 1/2, and a 2 as coefficients. Well, 2 and a half, when I multiply, become 1. So I think I just have x here. And then 2x minus 1 to the negative 1/2. And then on this side, 1 is 1, so I just have 2x minus 1 to the positive 1/2. Now, again, I don't want to say calculus is easy, but it's usually not that difficult. It's the algebra cleanup where people make mistakes. So we still have to clean this up. And I'm going to do a short little demonstration in the corner here and try not to take up too much room. I just want to review factoring. If I said 3x squared minus x to the 5th, what is the GCF that you could pull out? Is it obvious? You could pull out an x squared because it's the smaller one. It goes into both of them. Then this term you'd have 3, and this term you'd have x cubed, because when you multiply, you add exponents, and that would get me what I started with. So the key is, and maybe you want to make a little note for yourself, you want to factor out the smallest term. Okay, because there is a GCF here. They both have 2x minus 1, so there's a GCF, 2x minus 1, but we have to pull out the smaller term. So think of a number line. Here's 0. You have a half, and you have negative 1/2. Who's smaller? All right, so we want to pull out 2x minus 1 to the negative 1/2. When we do that, we're going to put a big bracket. So I have 2x minus 1 to the negative 1/2 I pulled out. So on this side of the plus sign, I'm left with x. Then I have the plus sign. Now I've got to figure out what I'm left with over here. Well, let's go back to my basic example in the corner. If I had a 5 here and I pulled out x squared, I ended up with a 3. So what did I do to these exponents? I did 5 minus 2 to get 3. So to get this exponent, I have to take what I have. I had a 5. I pulled out a 2. So to get this exponent, I'm going to put it over here. I had a 1/2, and I'm pulling out a negative 1/2. So I had a 1/2. I'm taking out, subtracting, and my GCF was a negative 1/2, or my exponent was a negative 1/2, which leaves me with a 1. So I have 2x minus 1, basically to the first power. So as I clean this derivative up, I have 2x minus 1 to the negative 1/2, and now I can add like terms in here. I have 3x minus 1. And believe it or not, I can actually go one more step. Because this has a negative exponent, I'm going to rewrite this. So I have 3x minus 1 over the square root of 2x minus 1 for my final answer. Now, I know that probably seemed like a lot, so this is where, again, it's good to pause it, rewind it, maybe even do it again in your notebook or on a scrap sheet of paper. All right, f of m equals 2m times m cubed minus 1. So notice I said times, and I'm going to compare. And in the first term, I have a variable. In the second term, I have a variable, so I definitely have a product rule. So let's talk it out. So I'm going to say f prime of m equals the first term times the derivative of the second, so I'll just leave some space, plus the second term times the derivative of the first. Okay, so I'm going to take the easy one. The derivative of the first term, the derivative of 2m, is just 2. All right, so I'll do the other one up at the top here. I have m cubed minus 1. If you're good to go, you can do it by yourself. Inside, outside, I'm going to bring the 2 down, keep the inside raised to the first, times the derivative of the inside. So m cubed becomes 3m squared. The minus 1 is a constant, so it becomes 0. So I'm going to put 2 times m cubed minus 1 to the first times 3m squared. So the calculus part's done. I just need to clean this up. So I have f prime of m equals, so I'm looking for coefficients, 2m, 2, 3m squared. So 2 times 2 is 4, times 3 is 12. M times m squared is going to make m cubed times this m cubed minus 1. Plus, this again is a coefficient, I have 2 times m cubed minus 1 squared. So now I'm just looking for that GCF. I'm looking on both sides of the plus sign, and if you're not sure what I'm talking about, maybe bracket it in, this side and this side, to say what do they have in common? What looks the same? Well, to me, it looks like they both have this m cubed minus 1. So I'm going to pull that out as my GCF, m cubed minus 1. The smaller exponent's 1, so I'm taking one of them out. Now a big bracket to show what's left. I just took this out, so I have 12m cubed. There was 2 here, I'm taking out 1, so keep my plus sign, I'm left with 2 times m cubed minus 1. And again, I can clean up inside there. So I have m cubed minus 1. This is going to get me 12m cubed plus 2m cubed minus 2. So that's 14m cubed minus 2. Okay. All right, I'm going to get a little more crazy and intense here. And this is by far probably the toughest video of all of them. All right. We have a quotient this time. We have x's on the top, x's on the bottom. So let's give this one a whirl. Quotient rule. Remember, low d high minus high d low all over low squared. Lots of self-talk. So I am going to rewrite this, of course, as 6x squared minus 5 over 2 minus 5x to the 1/2. Remember, we don't want to leave any radicals. All right, so my low is 2 minus 5x to the 1/2. D high, I'm just going to leave a blank for a minute, minus high, D low, all over the low squared. Okay, so I like to set it up, prep myself for it, and then I'll take my derivatives. Low D high minus high D low all over low squared. All right, so I need to start with D high. My derivative of the high is super easy because it's just the power rule. This becomes 12x, and that constant goes away. All right, the ugly one, of course, is this little chain rule, my D low. So I have 2 minus 5x to the 1/2. I'm going to derive it. So I'm going to bring down I'll put it in here right away. I'm going to bring down the 1/2, keep the inside, subtract 1, so subtract 2 over 2, so I get a negative 1/2, times the derivative of the inside, so times negative 5. So as far as calculus goes, I don't think that's bad. Again, it gets ugly on the cleanup, and that's the part we have to work on throughout the year, probably the most. So I'm going to go ahead and just highlight what I think is the GCF. So I'm looking at the minus sign, and I'm looking for something on the left and something on the right that they have in common, and they always will have something in common. I'm going to say this 2x minus 5 to the 1/2. So they have the 2x minus 5 term in common. So I can pull that out as a GCF. Now remember, you're pulling out the smaller. I have 1/2 and I have negative 1/2. Obviously, the negative 1/2 is smaller. So my h prime of x, I'm going to pull out the 2 minus 5x to the negative 1/2 and then bracket to show that's my GCF. So I took this one out completely. So I have 1/2 that I'm starting with, and I'm taking out a negative 1/2, which leaves me with a 1. So I basically get 2 minus 5x times 12x. There's my minus sign. I have negative 5/2 if I multiply those numbers, times 6x squared minus 5, all over. When I multiply this power to a power, I multiply. So I'm left with 2 minus 5x. And you could keep cleaning this up. I'm going to do one more step because I could probably talk for hours about this. And I already feel like it's getting long. This can go to the denominator because it's a GCF now. So I can move it back to the denominator. So I'm put it down here, 2 minus 5x to the 1/2. And I'm just going to cross that off here. And then because I'm multiplying, I can add these. So if I want to add 1 plus 1/2, I need a common denominator. So that's really 2 over 2. So I could really call this denominator 2 minus 5x to the 3/2. All right. So again, we want to take the derivative, and this time we want to substitute in the 1 afterwards. So I will rewrite this for myself again. This is 2x minus 1 raised to the 1/2. So hopefully you're seeing quotient rule. So I have dy dx. And I'm going to talk it through again. I have low d high, which I'm just going to leave a space, minus high d low all over my low squared. All right, so now I'll go through and I will take the derivative of the high. X plus 1, linear, so that just becomes 1, piece of cake. Denominator, though, is the chain rule. So I'm going to bring the 1/2 down, keep the inside, subtract 1, so minus 2 over 2, so I get a negative 1/2, times the derivative of the inside is 2. All right, so I don't have to do a ton of cleanup on this one because I'm just substituting now in the number 1. So I am just going to rewrite it for myself before I plug in the number 1, but I'm really not going to clean it up much. So I'm going to say dy dx equals, because I don't like to plug things in when I see fractions, so I just rewrite them. This is the square root of 2x minus 1 times 1 minus, this is x plus 1 times this 1/2 and 2 make 1. And this has a negative, so it's just going to go to the denominator of this term, this 2x minus 1. Notice it didn't go to the denominator of the whole fraction. It just went to the term it's touching because this is one term. And then the square and the square root cancel, so I get over 2x minus 1. And now I just have to substitute in a 1, it says. So 2 times 1 is 2 minus 1 is 1. Square root of 1 is 1. Here I'm going to get 1 plus 1 is 2 all over 1. All over 2 times 1 is 2 minus 1 is 1. So it looks like I got 1 minus 2, which is negative 1, all over 1. So I think I get a slope of negative 1. All right, I know I've been talking for a while. I've got 2 left for you. Like I said, this is by far the toughest video. Please do not stress if you are having issues, but do ask questions. And like I said, we're just trying to give you a taste of what we're going to get into next year. Please, this is one of the hardest topics of the entire year, just getting this chain rule down. Sometimes it takes kids a day. Sometimes it takes them a week. It even took one kid 5 months. So just be patient with it. It will come, I promise you. Just don't quit on it. So the first thing I want to do in this problem is rewrite this function. So notice I have 3x squared times this function here. So my first term is 3x squared. My second term, though, notice the squared on this stinker. So I'm going to rewrite this as the sine of 5x cubed, but then all of that sine function has to get squared. So are you comfortable on the rewrite? Obviously, that piece is easy. The squared is what we did earlier. So this does turn into a double chain when I derive this piece, because this piece is inside of sine, but then this whole piece is inside of the square. So I'm just going to take it nice and slow again and just kind of talk through my setup, and then I'll find the pieces. So it's a product rule because we're saying times. So I'm going to go first. Derivative of the second, I'm going to leave a lot of room, plus my second term times the derivative of the first. Okay, so I'm going to take care of the easy one. The derivative of the first, 3x squared just becomes 6x. Okay, now I'm going to do the ugly one. So I'm going to start with, so I'm going to this bear here. Start with the outer function, which is a 2. So that comes down in front. Keep the inside. Now go to the inside and derive. Sine is going to become cosine. Keep the inside. Now take the derivative of its inside. So that's going to get me 15x squared. And that's it. The calculus part is over. It's just kind of the cleanup now. So I'm going to see what I can multiply together. So this 3, this 2, and this 15x squared can go together. So what's easier? 2 times 15 is 30. And again, order doesn't matter. Do what's easier. So to me, I do 2 times 15 is 30, times 3 is 90. So I'm going to say that's 90. X squared and x squared make x to the 4th. Then I have the sine of 5x cubed and the cosine of 5x cubed. Now plus sign. Here, this is real nice. I have 6x, and then I have the sine squared of 5x cubed. Again, there is a GCF I could pull out, so I'm just going to do so just to say we've seen it before here. Notice they both have sine of 5x cubed. The square tells me there's 2 of them. Here there's 1 of them. So I would say my GCF is the sine of 5x cubed. And then I just have 90x to the 4th cosine of 5x cubed plus 6x sine of 5x cubed. All right, last one, I promise. Let's see, I've got 7x times the tangent to the 6th of 2x squared. So again, I'm just going to rewrite it first and then try to take the derivative on your own. And again, no worries if you're still a little confused. I promise it will come. We will have a lot of practice in class. But why don't you pause it, see if you can take that derivative on your own. Don't worry about cleaning it up. All right, so that's mine. Again, I didn't clean it up. So I've got my first term, the derivative of the second. So that's what I'll talk through. So 6 came down, keep the inside, raise to the 5th. Now I go inside. Tangent becomes secant squared, keep the inside. Now I go to that other inside, which becomes 4x. Plus, leave the second derivative of the first. If you've got that, congratulations, that's amazing. And again, if not, there are no worries. Let me just stress, no worries. It will come. And then lastly, I can just pull a GCF out. So again, my plus sign is here. It looks like they both have the tangent of 2x squared. I'm going to pull out the 1 to the 5th. Tangent of 2x squared to the 5th power. So I'm going to take out all 5 of those. So let's see, I have 7 times 6 is 42 times 4. I think that's 168. X times x gets me x squared. Secant squared of 2x squared. Plus sign. There was 6 of these. We took out 5. So that's going to leave me with just 1 of them, tangent of 2x squared. So that does it for putting chain rule with product and quotient, and we'll have a little practice for you.